project investigates the use of wastewaters in order to make an algae culture media suitable for commercial production of algae for biofuel.
The advantages of using wastewater is the fact that you are using nutrients that are going to be disposed of. In this case, you're having the algae use those nutrients, grow, develop more biomass, and ultimately biofuels. Otherwise, the nutrients are simply put in landfills or end up in the groundwater or in lakes or streams.
The research on algae has many potentials, mainly focused on people with a biology background. However, with recent research and development, there is a need of more broad disciplines involved.
It's a project that involves 3 graduate students from different disciplines: horticulture, molecular biology, and mechanical engineering.
Growing up on a farm in Missouri, I've always been interested in growing things. I've just recently had more of an interest in biofuels, and microalgae present so many opportunities.
I have to understand that I deal with living organisms here. I cannot put certain equipment that can damage some of the algae cells.
The process starts off with aerobic digestion. Here we use a 5-gallon bucket to release the nutrients from the wastewater. We scaled it to 1,000-liter digester batches where we were able to develop swine, poultry, municipal sludge, and ag runoff for use as an algae culture media. After we're done with that and we have a media ready, we have the preparation of inoculum. So a single colony will be streaked across. We do this to ensure we're using one strain and we know what strain we're using. We can take single colonies, pluck them off of the dish, and use it to start small amounts of inoculum in test tubes. From this stage, it will go on to a larger tube. Finally, it will go to a 2x2 panel, and then eventually we'll take it out to the field site. What starts off as a single algae colony on a Petri dish is eventually formed into trillions of workers at work cleaning phosphorus, ammonia, and nitrates from wastewaters.
The next stage after algae culture is the algae dewatering process. Here we've chosen a strain that can be settled within a day. The result from there is the final effluent, and it's low in nitrate, phosphate, and ammonia. Back here is a sample of the algae that's been dewatered.
This biomass was freeze-dried. However, solar drying may be employed on a commercial scale. So after harvesting and drying, we bring the biomass in here. So we put the biomass in with an excess of methanol in the presence of a catalyst, and it'll end up a crude product that looks similar to this. Then that can be further purified into a clean diesel product.
I think what is surprising to me is the fact that they were able to look at multiple types and get differential results. So not all wastewaters give you the same type of algae growth.
I can see the entire process to be commercially viable.
Industry will take an interest in this when you can affordably produce biodiesel.
What's exciting about it is students from different areas of science and engineering coming together and using their own unique capabilities to grow something that produces products that are very important from the standpoint of energy sustainability.